So we have got a maths question here. The question is coming from matrices. It is from a 2017 paper. So 2017 paper 2, question 1A. So this is question 1A. The question reads, given that matrix M equals row 1, 3, negative 2, row 2, 5x. The question says, find the value of x for which the determinant of a matrix M is 22. So find the value of x for which the determinant of matrix M is 22. So in this case, we have already been given the determinant. Note that this is a 2 by 2 type of matrix. So we have M equals. So make sure the matrix is always represented by the capital letter. That is very cardinal. So this is what we have. So now we are going to use the formula for a 2 by 2 matrix. So just an illustration here. Suppose M and D, A, B, C, and D. Then the determinant, which is represented by this, or det of M, will be multiplying the major diagonal first. So we're going to have A times D. That answer, you always put a minus here, and then subtract the product of the minor diagonal, which is C times B. So this is what we are going to make use of. So these elements, we are going to relate them to this one. We are going to write the formula. So we are now back to our question, which is M, the determinant of M. Here we said A times D. If you compare these two, you find that A is 3 and D is x. So it is 3 times x. Then minus, we see C is 5 and B is negative 2. So exactly what we did, we multiplied these two and then put a minus and then multiply these two. Same case, 3 and x have been multiplied. We have put a minus. So we just need to multiply 5 and negative 2. So 5 multiplies negative 2. Note that we have got our M, the determinant of M is given to be 2, 2. So we are going to replace this symbol for determinant of M with a 22. So we are going to put a 22. Then we'll say 3 times x, it is 3x. Then we have a minus, and then we multiply 5 and negative 2. We are going to have a negative 10. From there, we will simplify the right side, which is going to give us a negative and negative will be a positive 10. Our aim is to look for x, or find the value of x. So we can see that this part is related with a variable, but this one is not having a variable. Hence, we take it to the other side, or we find the additive inverse. So we're going to have 3x. This 10 will cross the equal sign, or we're going to find the additive inverse, which is negative 10. So we're going to have 22, which is already there. We have just moved it a bit, and then the 10 goes that side. But since it has crossed the equal sign, as traditionally the way we use it, we are going to say negative 10. From there, 22 minus 10, we are getting a 12, giving us 3x. Our aim is to look for x and not 3x, so we are not yet done. But after dividing by the number 3 on both sides, we are going to obtain the value of x. 3 into 3, 1 times x, we are going to have x. Then 3 into 12, it's a 4. So we have found the value of x. So we can say therefore x is 4, and m will now become 3, row 1 3, negative 2, row 2 5, and then we replace x with the 4. So that is our value for x. So now the next question is saying, hence find the inverse of the matrix M. Hence find the inverse of the matrix M. So whenever they use the word hence, hence means you are from doing something that has to help you to work on the other part. So since the word hence has been used, it means we have done something that is related to what we have to do now. So in short, let's make use of what we have found in the next question. So we are looking for the inverse of m. Okay. So that's number 2. So let's not forget we had the matrix M equals row 1 was 3, negative 2, and then row 2 was 5 and 4. Then from the statement of the question, we were given that the determinant of M is 22. So that's what we are given. So whenever they give you the question of finding the inverse of a matrix, which is a 2 by 2, make use of the formula that I'm going to share with you. The inverse of a matrix will be represented like that. Then the formula is 1 over the determinant of that particular matrix times the adjoint of that matrix, of the matrix which we have used. So that is the formula. In other language, it can be written as inverse of a matrix M over determinant of matrix M times adjoint, which we can shorten to be like that. So we are not worried about the determinant here because we already have it. We are worried about the adjoint. But if you already have the matrix, which is, I'm just rewriting it just to keep memory short. If we have got this matrix, then its adjoint is not difficult. We are just going to use two rules. We swap this major diagonal. Remember, the diagonal that you multiply first when finding the determinant is the one which we swap the values. So in this case, we are saying 4 will go where 3 is and 3 will go where 4 is. So we are going to have 4 and a 3 there. Then for the other matrix, for the other diagonal, we are going to multiply each number by a negative always. So these rules do not change. Here you always swap when you're finding the adjoint, and here you always multiply the number by a negative. So I'll multiply this 5 by a negative, it will become negative 5, and I'll multiply this number by a negative. So negative and negative will give me a positive. Hence now I've found the adjoint. But remember, this is not my aim. My aim is to find the inverse. So I'll say inverse of a matrix M is equal to 1 over the determinant. I'm already given a 22. So I'll put a 22 there. And then for the adjoint, please, just take the way it is and replace it there. Okay. So this is the final answer for the inverse. So if we have got the matrix there, the determinant was given, we use this formula. Then from there we need to find the adjoint, which is done by swapping the major diagonal values and putting multiplying the minor diagonal by a negative. We multiply a negative, it will become negative. We multiply a negative, it becomes positive. So this is how the question was supposed to be done.